Welcome. I'm Amanda Hickman. I run the BuzzFeed Open Lab for Journalism, Technology, and the Arts, and I'm really excited to moderate a fantastic panel today. We have Chen-Kai Lee, who's going to be showing us a tool called iCheck that compares, am I wrong? You are right.
ClaimBuster.
ClaimBuster, dang, Brett is iCheck. ClaimBuster, which employs machine learning to identify statements of fact and has had some great successes testing what they find against what fact-checking organizations have identified as checkable claims. Brett is going to be talking about iCheck, which provides some really interesting algorithms for comparing voting records and comparing allegiances between politicians and sort of checking their claims to be particularly allied. And then Toby Konitzer is going to be providing us with some interesting strategies for changing how we conduct polls. So I think it's going to be really interesting. And we're going to hear from all of them, and then we're going to take questions at the end, so you can sort of take notes and save up your questions. So with that, Chen-Kai, do you want to get started?
Good morning. So in this election year, fact-checking has become a household terminology. Okay, many news organizations and their fact-checkers have worked hard on deliver live coverage of presidential debates. So, for instance, on the past Monday, okay, we have various news. Oh, you're not seeing the slide. On the past Monday, Bloomberg TV, they had live fact-checking on screen. The host of the presidential debate, Lester Holt, he did some fact-checking himself on two of the candidates. And the website of factcheck.org went down because of the heavy traffic they received. NPR's real-time fact-checking website received, I think, over 6 million visits on the debate night. So the keynote speaker gave us some very good example of fact checks done by PolitiFact, so I don't need to repeat the examples. What I wanted to add is that I wanted to include some examples of pants-on-fire fact checks from PolitiFact, but I couldn't find any from the debate night. So that seems to show that the two candidates were quite honest on that night. In the past 1.5 years, we have been developing this tool called ClaimBuster, which helps fact checkers identify important factual claims from various sources of text and political discourses. We have been applying ClaimBuster on all 21 primary debates from August 2015 to April 2016. And we did the live coverage of the first presidential debate. We're going to continue to do the same for the remaining debates. We also, ClaimBuster is also constantly monitoring tweets and retweets important factual claims it finds in people's tweets. And recently, we also started to use ClaimBuster to monitor the transcripts of proceedings of the Australian Parliament. This is a screenshot of ClaimBuster on one of the past debates. As you can see here, we have the transcript of the debates, and the sentences from the transcript are highlighted by different shades of blue, corresponding proportional to the scores they received from ClaimBuster. The scores indicate how likely these sentences contain important factual claims that should be fact-checked by professional fact-checkers. We also have some user interface features that allows users to annotate these sentences and have discussions on these sentences while they collaboratively work on vetting these claims. The website also has some visualizations on ClaimBuster scores on the sentences by different speakers. And the right part of this slide is the device that we use to get closed captions from live broadcast of the debates. I mean the small box in front of the TV, not the trash can, of course. So this is the diagram of ClaimBuster, the workflow of ClaimBuster, basically. It's essentially a supervised learning task, right? So we collected the transcripts of all 30 general election presidential debates in the past. And then we created a website to basically crowdsourcing website to use human annotators to label these sentences with regard to whether they contain important factual claims or not. And then, so this becomes our training data or ground truths. And then we extract features from these sentences, and we tried various combinations of the features. We tried various classification models and ranking models. So the classification and ranking model becomes basically the core of ClaimBuster algorithm. We apply that model on sentences from future events like the presidential debates. And for a sentence, ClaimBuster will provide a score on the sentence to indicate the likelihood of that sentence containing important factual claims that should be checked. So in this way, it essentially provides a priority ranking of the sentences, which can help fact checkers to prioritize their work, to focus on the highly ranked sentences, instead of painstakingly sifting through a large number of sentences. And so the training data, the data set that we used includes transcripts of all 30 general election presidential debates in the past. So there have been 11 general elections that had debates. In total, we had about 20,000 sentences by the candidates. And these are the sentences with at least 5 words, right? And so we created this website that basically solicits input from human annotators. For each sentence, we ask them to select one of the 3 choices, whether the sentence contains an important factual claim, a factual claim but not important one, or it doesn't contain any factual claim. Now, with that, we build the models that I mentioned earlier, and the details of these different features and the ranking and the classification models were discussed in other publications. So I'm not going to discuss those details today. Instead, the C+J paper that I'm presenting today mostly focus on experiments that we did to show that ClaimBuster agrees with human fact checkers in deciding on what should be fact checked and so on. So for that experiment, we used the 21 primary debates that took place in the last 13 months. So that includes 12 Republican debates and 9 Democratic primary debates. There are about 30,000 sentences in these 21 debates. Okay, we detected topics associated with each sentence. This is done by adopting the 12 most important topics that are used by Gallup in their public opinion studies. And so basically for each topic, we manually created a list of keywords, and then we try to see whether a sentence contains a lot of matching keywords from a topic, then we will assign that sentence to that topic. If the degree of matching is not sufficient, then we do not assign any topic to a sentence. So after that, we also manually collected all the fact checks done by PolitiFact and the CNN on these 21 primary debates. So I'm going to sort of summarize some of the more interesting results from our experiments. Number one, so we find that sentences selected by CNN and PolitiFact for checking, they had significantly higher scores from ClaimBuster, higher than sentences not selected by them, right? For instance, the average ClaimBuster score received by sentences checked by CNN was 0.433. This is compared against 0.258 as the average score for sentences not checked by them, right? So there's a significant difference here. This suggests that claim buster and professional fact checkers, they agree on which sentences should be fact checked. And this, these two figures show us the distribution of topics over sentences scored high by claim buster and topics over sentences scored low by claim buster. So 0.5 is used as a threshold for high scored sentences, and 0.3 is used as the threshold for low scored ones. And as we can make some interesting observations here. For instance, the Republican candidates, they spoke about healthcare, but they tend to use fewer factual claims when they talk about healthcare. And this figure shows us the distribution of topics of highly scored sentences from claim buster, as well as distribution of topics over sentences checked by CNN and PolitiFact. And what we can see is that claim buster and CNN and PolitiFact, they demonstrate very similar distribution of topics in terms of what they consider as things that should be fact-checked. For instance, for this topic of economy, all these three different, both CNN and PolitiFact and ClaimBuster, they have over or close to half of the sentences belonging to the topic of economy. One exception is, I believe, is social issues. So there, CNN and PolitiFact had a fairly large portion of sentences checked by them belonging to this topic, but ClaimBuster has a small percentage of sentences scored high that are in this topic. So ClaimBuster is only the initial step that we are taking in our quest to automate fact-checking. So this diagram depicts our long-term goal in terms of what we want to achieve eventually, right? So ClaimBuster is going to monitor sentences and text from various political discourses and narratives that include debates, interviews, and speeches, as well as news articles and social media posts and web pages, right? We will create a repository of known fact checks done by professionals, and then we will use ClaimBuster to identify important factual claims that are worth checking from these various sources of text, and we will match the factual claims we find using ClaimBuster with the repository of fact checks. If there's a matching fact check, we will use various ways to deliver the fact checks to the voters. If it's a new claim that's never been checked before, then we will provide algorithmic approaches to help fact checkers to fact checking, as well as various facilities to help them coordinate and discuss during fact checking. So of course, this is a very ambitious goal, right? But I believe it's a very useful eternal quest that will guide us in making progress toward automated fact-checking. Perhaps fully automated fact-checking, live fact-checking is not possible, at least not possible in the near future. But I believe one day, far into the future, perhaps robot fact-checkers will dominate because they are less subjective, right? So we have seen criticisms received regarding fact checks, regarding fact checkers being less objective, right? So these are various news headlines I collected regarding the fact checks. And robot fact checkers, they will not be tired, right? So this is a satire article from the New Yorker. I had no problem in believing that was true, actually. And then perhaps programs are more intelligent. Okay, so I'm going to skip in the acknowledgement and so on. We received funding from the National Science Foundation and the Knight Foundation in developing this tool. So I believe it won't hurt them it won't be a too bad idea for them to give us more support. Well, these are the QR codes for our project prototype as well as our data collection website. So I believe we will take questions afterwards.
Yeah, we'll take questions at the end.
Thank you for listening.
Okay, so Chenkai and I work on the same project, but I'm going to come at it from a very different slant. So in the quest to automate fact-checking, it's obviously a very difficult problem. There's a great question at the end of Jeff's keynote, which was, given somebody's Twitter feed, could you give a score as to how accurate or how likely this statement was to be truthful or not? And I'm going to show you a couple of instances where even if we're given very concrete data, very concrete questions, the process by which you fact check is very nuanced and very difficult. So I'm going to give you two cases here, and then I'm going to probably do something stupid at the end, which is give you a live demonstration, which is consider the case of voting records. So voting records are often used as a way to attack a candidate or to defend yourself. Right now in the state of Indiana, Evan Bayh, who's a Democrat, he was in the Senate for quite a while, then he dropped out for a session or two. Now he's trying to run for re-election again, and one of the attacks people are using against him is that outside GOP groups running ads against Bayh have attacked him for voting with the president 96% of the time. The similar thing happened in North Carolina, which is where I'm from, which I'll get to in a second. And then there's another type of claim that people love to make, specifically people currently in office, which is I was the most bipartisan senator in some Senate or the House. This particular one was made by Scott Brown, who was in the Senate for Massachusetts in 2013. But there are problems with this. So what I'm showing here is that fact checks can be correct, but they can still be misleading. So this is kind of a rank view of how everybody votes with the president. So the president comes out and he makes a bill, or he makes a, I support this bill. I don't think we should pass this bill. And then, GovTrack.us will track how all of these people vote. And then we can kind of tabulate how they vote with the president over time. So this is a rank view of how Evan Bayh voted with the president during December 2009 to November 2010. Now, what you'll notice is that the fact is correct, but Evan Bayh is actually pretty low when compared to all the other Democrats. Now, you'll notice there's a pretty perfect divide here between Republicans and Democrats. And they're the two independent senators, which are the odd colors in here. So the interesting thing is that when you put it in context, he's actually only in the top 46th percentile. So maybe it doesn't look that bad. These claims come up every cycle. So the Kay Hagan claim, she was a senator from North Carolina when I first got to Duke. And she was in an election battle with Tom Tillis. And at the time, nobody wanted to be associated with President Obama, so Tom Tillis repeatedly used this attack against her. And if you know anything about North Carolina, it's almost a perfect split right now between Republicans and Democrats. So any type of sway that you can get to the other party is worthwhile. Currently running is Mark Kirk. He's in the Senate, and this was published not by him, but by somebody else. And it says his bipartisan appeal is tied to his maintaining a voting record that keeps the National Republican Party at some distance. But if you read the second sentence, I don't really know what this is saying. So it says, in the 114th Congress, he sided with his party 72% of the time on votes that divided the two parties. And so it's this last part that's very open to interpretation, I would say. So what we did was we made this system. It's called iCheck. I'm going to show you a demo in a second. If you see the domain, don't go there until I'm done with the demonstration. That'd be great. So basically what it does is it's going to compare groups of legislators' voting records. You can go through, compare various facets. You can group people together by state. We've collected a bunch of special interest groups. You can view them by chamber. You can compare how they vote with different political parties, Democrat, Republican, and president. essentially what we want to do is be able to put them into a context that makes sense so you can decipher these claims. And this should illustrate two things. One is the difficulty of, even if we have a very specialized claim, such as this vote correlation claim, how much effort it takes to actually be able to automate some of these processes. So whenever anybody goes through, and so for instance in the Kay Hagan claim, a bunch of people for WRAL in Raleigh went through and did the fact check, and they basically did the story I'm going to take you through. And then secondly, we want to present these perturbed perspectives of a claim. So if you change the set of legislators, say you drop the state requirement, how do they fit in this broader context? So I'm going to tell you two stories here. The first is that iCheck can be used for fact checking. I'm going to tell you the Evan Bayh and how he voted with President Obama. And then I'm also going to tell the story of how Republicans in the House stopped voting with the president during the October 2013 government shutdown. So let's see. Okay, so I'm going to start with Evan Bayh. Here we have an initial setting. So it says that Evan Bayh voted with the president 85% of the time between 2009 and 2010. And here you can see, if I hide over him, he's somewhere down there in between. So now one of the neat things that we can do is we can change this time period. And say we just wanted to select a specific year. We've done a lot of work to be able to do this in the browser. So now say I have it just at a year, and say you wanted to find some setting where he was at the highest. So he was at the highest, he voted the most with the president, so to speak. Now Evan Bayh is going to be a special case because he's going to drop out of the Senate here. So we don't have all of the data, but you can kind of see there are actually some instances where he's the lowest Democrat. So if I was going through and doing a fact check, I'd be able to say, not only is he the lowest Democrat, some Republicans actually beat him in how they vote with the president. And so we can play this game. You can also see how the population changes. You can see that Bayh tends to hover towards the bottom. So this gives you some context that regardless of the time period I change, oh, sorry, this mouse is sensitive. Regardless of the time period that I change, Evan Bayh tends to be towards the low end. Now we're also going to give you some extra contextual claims. So we're going to break it down by all these different populations, see how he compares on the key votes. So the idea is that a journalist comes to this site, they see some claim on Twitter or wherever, and they want to use this for research. They can go through and come up with these claims, see how these claims hold up over time, over all of these different perturbations. But the thing I want to close on is probably something that is either funny or sad, depending on how you view the state of our government. So this is going to show you how the House of Representatives voted with the president. So I'm going to go back really fast so that you can't see the story really quick. But basically, okay, so let's start at 2009. Let me go to a year here. Two things are going to happen in this data set. The first is that the House of Representatives is going to switch between Republicans and Democrats. So there's going to be a Republican majority that enters sometime right around 2012. Right around 2013 is going to be the United States House government shutdown. And so I want you just to kind of watch what happens to this chart as it changes. So I don't know if you can read the numbers, but there's a good chunk of Republicans here that hover around 50% voting with the president. So as I walk through, it seems to be fairly consistent. There are some ups and downs. Most Republicans, though, are somewhere around 30%, which you might say is pretty low. So here we see the first switch. So now it's switched from Republicans are in control of the House. And let me just keep going. So you can see here, this is kind of interesting. There are some Republicans that are up by 50%. And now something interesting is about to happen. So when the House of Representatives got into this dispute with President Obama, one of the things they did was almost entirely stop voting with anything the president took a position on. So here we can see it jumps back up a bit. This is actually because we don't have too much data during that time, but here you can see that there's a good chunk of representatives that almost entirely don't vote with the president at all. So now the question is this just a president phenomenon, or does this happen just with Democrats in general? So I can go through and I can explore. I can see how everybody in the House, let's say how they vote with the Democrats. This might take a while because, of course, I didn't think to preload it ahead of time. And then this will be my last statement. But basically, the keynote here is up at top. So Republicans voted with the Democratic majority on average 56% of the time, which when you think about it, that's much higher than the average of 20% of the time with President Obama. So you can use this tool to kind of tell a story if you wanted to. And the story here would kind of be that, at some point, this message went out that, hey, we know that the president's taken a position on this specific bill, maybe we should vote against it even though we agree with it. So you can see that the same, viewpoint exists, but it's not quite to the extreme that, you would think it is. Although, interestingly, so if you go back all time, you can see how it shifts. When the Democrats are in control, Republicans are forced to vote much higher with the Democratic majority. And that's all I have.
Hi, thank you for the nice introduction, Amanda. I'm Toby Konitzer, and I'm going to try to convince you today of two things. One is that polling, especially political polling, is not dead. And the other thing, that if you run a small news outlet, that you can use polling cheaply and effectively to have investigative journalism or to come up with stories of interest to your readers. So how are we going to go about this? I'm going to talk a little bit about the history of traditional political polling. I'm going to see how our approach is different than traditional polling, how it is useful for your newsroom, and then we're going to walk through a couple of examples, mostly from the 2012 and 2016 presidential campaign, where we use our form of crowdsourced polling that I'm trying to sell to you today. But we're also going to have some non-political examples stemming from healthcare. So first of all, let me talk about a little bit about the history of political polling in the United States. And we all know, or maybe most of you know, that the first major poll in American politics was a disaster, right? So in 1936, the Literary Digest made this claim that Republicans are going to win the next election by a landslide based on a 2 million mail-in survey. And of course, we know that actually Roosevelt won the election instead. Right? So how did that happen? Well, you might figure that the readership of the Literary Digest is not exactly representative of the American population, right? Skewing wealthy, more car owners, certainly not representative of this sort of New Deal alliance that marked American politics in that time in the 20th century. So then we had a small group of scientists around George Gallup who came up with a different notion of polling. Right? And they, first of all, revolutionized the idea of polling, but they also rebranded how we understand political polling. So first of all, they introduced this idea of actually obtaining a representative sample frame, right? So giving every individual that we care about, so every American voter, the same non-zero probability of being included in the sampling frame. But they also understood political polling as a new means of accountability mechanism. Right? In American democracy, before that, the only way to ensure that the presidency and the public opinion of the people are aligned is via elections every 4 years. But now with this new way of polling, you would have theoretically the idea, even in off-election years and off-campaign times, to understand how far aligned the president is with the public opinion. But today, this, and I should say that this sort of idea of probability polling emerged from address-based sampling, where you you just go through a telephone book and you select addresses randomly to now random digit dialing, maybe in the modern era. I'll talk a little bit more about that. But more importantly, today, this form of probability polling suffers from many, many weaknesses, especially if you have your own newsroom and you might not have the big bucks to dish out for RDD polling, random digit dialing polling, or other forms of representative polls. So first of all, the hallmark of probability polling, RDD polling, now suffers from mostly or sometimes single-digit response rates, right? And you can understand if this non-response bias is sort of proportional to your political beliefs, your sample becomes biased even though the initial sample frame was actually representative of the population. But another problem that you have if you run your own newsroom is that these things are darn expensive. Right? So a dual frame poll via probability polling, dual frame meaning including cell phones and landline phones, now will cost you between $25,000 and $30,000 for 1,000 respondents. So if you just have, an issue that you care about, you want to report on a Wednesday on this issue, you think about it on Monday, you certainly might not have the resources to dish out that kind of money. So what this means is that it's incredibly difficult to field DIY for smaller news outlets. And this also means that we'll also see sort of only top-line vote intention polls, right? And only the major news outlets can really afford to purchase this kind of representative polling. So what do we propose? Our proposed remedy is what we call crowdsourced polling. And I'm going to walk you through a step-by-step guide conceptually. But I want you to think about, I want you to go back to this Literary Digest example and understand that this data could have been salvaged with the right statistical algorithms on top of the raw data, with access to the right secondary data, and with modern computational powers. And this is exactly what we propose to do. So, what we call crowdsourced polling is the following. The first thing you do, and I'm talking about, from the perspective of a journalist who works in a small news outlet, the first thing you do is you crowdsource vote intention, public opinion, or whatever it is you care about of matters national or even hyperlocal from your readers. And I'll talk more about that later. This could be done via smartphones, but maybe most easily could be done via online polls, and we've done something similar, and I'll talk about that more. Then you apply a statistical algorithm on top of the raw data to derive estimates for fine-grained subdemographics. What do I mean by that? Well, you'll obtain an estimate, for example, from your vote intention poll that you launched online to see how, say, black registered Republicans who reside in the South, who are between 25 and 29, with a median level of education and a median interest in politics, would have voted. And the nice thing about this approach is that we do not actually have to have a representative of this subdemographic in our data because the model works with pooling. And I want to say at this point that I'm going to take questions on the methods later. I don't want to talk about the methods too much, but I would be happy to do so. So what we do now is after we have obtained these estimates for subdemographics, we weight these estimates according to the known proportion of this subdemographic in the overall population that we care about. So you're going to say to me, well, how do I know the overall proportion of that subdemographic? Now here I have my estimate of the blacks who reside in the South who are between 25 and 29, yada, yada, yada. But how do I know what percentage this demographic is of the overall American voters? Well, there's two answers to that. One is voter files, and in fact, many news outlets now prescribe to voter files, but they're very expensive, sort of six-figure deals per year. So maybe that is not feasible for smaller news outlets. I say there is also data in the public domain, just census data that you can aggregate yourself, and oftentimes it performs better than the voter file data. And the last question is, does it work? And my satisfying answer to this is, yes, it does. But seriously, you can push back on this. We've done a series of validation studies together with Pew, and we've found very encouraging results where we show that in some cases, this form of crowdsourced polling works actually better than representative, expensive polls. Okay, so let's talk about a couple of examples. And we have very different data sets. I'm going to talk to you about how these raw data sets are biased. and what we can do to correct the bias based on our method that I just outlined to you, which, by the way, we call post-stratification. So the first data set that I talked to you about comes from the 2012 campaign. It is collected via Xbox, right? Clearly not representative of the general population. Skews young, skews male, and who would have thought that about gamers, but also skews heavily Republican? But what we can do is we can apply the method that I just outlined to you, and we can also do so for very fine-grained geographic units of interest, right? So for example, here the designated market area. So what you see on this map is you see movements in the Obama margin from September on the left to October on the right at the DMA unit. Okay, so that is something we might care about if we're interested in the effect of political advertising, say, right? So something, you could do readily at home if you collect the data via your own internet site, for example, right? So this is something of interest. We see a lot of stability, which is a good sign, that we shouldn't expect too much movement. We, in general, see a sort of bluening of the map, which makes sense given what we know about that campaign, right? So that's one example. But another example that is maybe more interesting to journalists is crowdsourcing via online polls. Now, this is data we collected in June 2016 via MSN.com, right? We got actually over 1 million respondents for that. That you might not manage to do or might manage to do. It's quite a big number, but it doesn't matter as much. What is more important here is that we just asked a very simple question, and I should have put the actual question up on the map. We also asked, who do you think will win your state? But we asked a simple question, who will you vote for in the next presidential election? At this point, it wasn't clear that Hillary Clinton was the official candidate. So that's a very simple, the simplest poll that you can imagine, right? The stupidest sample, stupid opt-in, very hard to correct, right? As we would expect, MSN.com audience skews very, very old, more Republican-leaning. I suspect that most of you do not regularly surf on MSN.com, and I don't blame you for it. After applying our post-stratification model that I outlined to you earlier, we actually obtain a map of colors that should look very familiar to you, right? It looks very similar compared to maps that were obtained from RDD or other probability pollings that show the states that are blue and we expect to be blue are blue, and the states that are red and we expect to be red are red, right? And I guess for Jeff Hancock here, reassuringly, some of the swing states are leaning a little bit blue here. So that might be good or bad, depending on where you come from. But you can also do something else with crowdsourced polling. Say, for example, you were to collect your data via smartphones and not via online polls. And we've done some experimental work with pollfish.com, which is a startup that collects data via smartphones, mostly via Android operating systems. And what this gets you is a bunch of secondary data, right? So I get, what kind of apps does my respondent have installed, and more importantly, the whereabouts of my respondent. Now, what I show you here on this map is the whereabouts of a single respondent within a single day. Now, it is very easy to see how you could use this kind of polling to derive adaptive questioning, especially on matters of hyperlocal interest. Say there is a local football game, high school football game in town, you want to poll people who actually went to that game, that is a way to do it. It is a way to conduct polls on traffic and all matters that sort of move and are local. So very interesting here as well. And I know this map looks a little creepy, but if Pollfish does collect this data, you apparently agree to the terms and conditions that Pollfish is allowed to share this kind of location service with the vendors, in this case us. But if we think back to our perspective from the news outlet, we can also use this approach for matters completely non-political. Say I'm running a small health-based journalistic outlet, and I'm interested in, say, treatment ratings and what treatment ratings are effective. Now, for that matter, we have paired up, my co-author and I, David Roschild, have paired up with a small startup here in the Valley called healthoutcome.com, which collects patient treatment ratings. We have run our same algorithm, and we've compared the effectiveness of two treatments, surgery and postural modification for lower back pain. And what we actually show here is that you're almost 3 times as likely to be cured by this postural modification as opposed to surgery, which is a much less invasive and cheaper treatment, right? And also here it is clear that this sample is skewed as well. This sample skews older, it skews more female. Apparently females are more willing to write reviews online. But again, with this method that I outlined to you, we can correct for that, right? And that is my last slide for today. No, that is my last slide for today. In conclusion, I think crowdsourced polling is cheap, and enables news outlets of all sizes to conduct their own polls spontaneously with maybe only a day to turn around the data, with flexible geographic granularity, and without knowledge of the exact statistical algorithms that go into this, right? So I said sort of jokingly, if you have one guy who knows R, you can do that as a news outlet. You can collect your data for free, you can run this algorithm on top of it, and you obtain representative estimates, right? The predictive accuracy of crowdsourced polling is as good and sometimes even better than the accuracy of representative polls, and I'm happy to talk more about that as well. And it allows news outlets with limited resources to conduct this sort of adaptive polling, right? Which is especially important for local news in matters of hyperlocal interest. So, as I promised, this is really my last slide. I want to thank 2 people who are in the audience. One is Sharad Gul for always being very responsive to questions and having good feedback on all the stuff we work on. And the other is Ofer Ben Shachar, who's founder of healthoutcome.org, who provided the treatment ratings data to us. So thank you very much, and I'm looking forward very much to your questions.
So if we have 2 mics in the aisles, and if you have questions, it would be great if you could come all the way to the mic. If you can't get to the mic, you can raise your hand and I'll repeat it. But we've got 1 question.
I knew I was strategically positioned. My question applies to everyone here, which is to what extent you're able to publish your code or more details on the algorithms you used. I see through the first speaker's Twitter profile that it's trademarked, and I don't know what kind of like intellectual property kind of sentiments you have around that. But at the very least, it sounds like the last speaker suggested that people broadly could apply the algorithms he described to their polls. So is that code available online? Is it like open source?
So I'm going to have everybody answer that because that was going to be my question too. Do you want to give us a snapshot of kind of how much of your code is available now, how much of it is open source, and whether there are other ways people can use what you've built?
All right, so for Claimbuster, we actually made some effort to explore commercialization opportunities, and we are still exploring that. So at this moment, we are not planning to release the data and the source code, but we are working on a public API that allows anybody who wants to use Claimbuster to basically send us a URL to a file on their server or a location of a cloud-based shared folder that contains any file they want to apply Claimbuster on. And they can also do this through a Slack chatbot. So we are developing that as well. We are also developing our API so that anybody else can develop their own Slack chatbot to communicate with our API. So we expect to have this API, at least a part of it, ready in the next, actually, is today October already or no? Okay, so next month, yeah. That's the status of Claimbuster.
And Brett, what's the status of access to iCheck?
So iCheck is, we have no problem making it open source. It was basically a research project that got out of control. And there is just one restriction, which is one of the sources of data is typically tied to institutions only, and that's Congressional Quarterly. So that can be a little tricky, but what we'd really love to see is somebody apply it at the state level. There's a lot of state vote tracking, so if somebody wanted to do that, we'd be definitely open for it.
So I will answer the question as well really quickly. We're currently working on an R package, and after the fact, you can essentially run this on the click of enter, or I guess Control R in this case. But in the meantime, I'm very happy to share every code that we have for journalistic purposes. So if that's something you are interested in, please approach me, because it might be a month or 2.5 before that R package gets released.
Cool. And it looks like we've got one question here, and then I'll take Peter's question from the middle.
Question to the last speaker. One of the challenges with online polling is gaming, right? So in fact,
Gaming.
gaming.
Yeah.
So for example, right after the debate, we saw that all the online polls showed that Trump had won by a landslide, which wasn't the experience of people who watched the debate or went to Twitter or read any of the editorials or whatever. So, and it turns out that on Reddit and 4chan, there were instructions on exactly how to game the polls, how to use incognito mode, and so forth. Additionally, there are bots at work, more so in this election than before, that do a lot of posts on message boards and Facebook, and also happen to potentially participate in these polls. So establishing that person who's voting in these polls is actually a real person, and the fact that they're not voting multiple times is a challenge. So how do you handle that?
Yeah, it is a real challenge, and it's especially a challenge in this election, and I'm very happy you mentioned 4chan, because you have these efforts, concerted efforts to game these systems. I think one approach would be to only use or work with logged-in users that have somewhat of an established identity. We haven't done that in the polls that we ran via MSN.com, so their incognito mode is indeed a problem, but I suspect that, given that we work with crowdsourced or convenient samples anyways, a way around that would be to work with logged-in users that have some sort of a known identity in some granularity.
Peter, I'll repeat your question if you want to just throw it out. I was going to make Toby rephrase that question, so.
I thought you were going to.
No, it's too long. For folks who couldn't hear it, the question is sort of boils down to what is the reaction from traditional pollsters to this method, and how does this compare to some of the things that folks like YouGov and SurveyMonkey are doing to correct for sampling bias?
Now, I think a good way to think about that is that there is two ways of correction. One of them we could call pre-sampling analytics, right? Something that RDD does. You develop a sample frame, and you have some analytics before you sample. And the other is post-sampling analytics, which is, and you're correct, purely what we do, right? We do no pre-sampling analytics. Now, YouGov does a matter of both, in fact, right? They have this panel that is somewhat representative, and then they draw with some mechanism from this panel. They used to have weights, which is sort of a, we believe, inferior way to do the same post-sampling analytics that we do. But now they actually provide the data without weights. But what I want to say is that you're right. This is going to be a big debate. I think you see more of that crowdsourced polling now being accepted, being reported on in places like The Upshot. But it is going to be an ongoing debate. I think ultimately, though, the problems that probability polling faces with declines in response rates lead to the fact that there is more and more skeptics to this idea that something like probability polling even exists in our time. So it is a controversy, but the movement that I've seen over the last 2 years has certainly been one in favor of non-probability, or what I branded here as crowdsourced polling.
All right, we have a question at the mic, and then another question. So we got this mic first.
Right, so my question is regarding the last presentation about polling. So it's very interesting. So you guys bring up an interesting alternative to the standard RDD polling. So, but the ultimate goal for polling, right, is trying to predict what's going to happen next. Let's say, I may miss this in the presentation, so I'm thinking, have you ever done any kind of analysis about if you guys, using your polling method, were you able to predict Trump won the primary? Were you able to predict Britain exit Europe Union? Were you able to do that? Because the polling, the goal is not saying, okay, I compare with another polling, I beat that. That's not good enough, right? We want to know what's going to happen actually in real life. Have you done anything on that?
Yes, I'll give you two examples. One of them I'm a little ashamed about. We did predict Brexit correctly. At this point, we were not fully believing in our own method, especially compared to a giant like YouGov, and we didn't make it widely public. So that's one piece of evidence. I think the more stable piece of evidence is a slide that I had in the extras. We have done a validation survey with Pew, where we pulled benchmark items where the proportions are known from the census, and we actually find that with our method, using data from the public domain, we beat the raw estimates and even the weighted estimates quite comfortably. And we beat representative polling as well. So in that case, I think we have outlined that our method is successful.
Another question at the mic.
How much differences there are in open source and proprietary codes? Because 538, they use R in open source, and they seem to be pretty good at what they do. And how do you verify? Do you use a Bayesian model? Yes.
Is that specifically for the polling question, or are you interested also in the fact-checking?
The fact-checking.
Okay.
So I'm not sure if I get the question exactly. Can you repeat the question again?
So
I was assuming that's question.
How much opportunity is there really in proprietary code? Because 538, they use open source. It's not a matter of your method, it's a matter of what your outcomes are and how fast you come up with them. So is there any real opportunity in proprietary code? 538 is the benchmark for polling predictions in journalism right now, and they use open source.
Yeah, so it's good to know that. Well, maybe, well, to be honest, we perhaps didn't really think too much about whether it's a better route to open source or not. So yeah, I'll do more investigation and figure out.
Okay, then in regards to the fact-checking in your machine learning and the outcomes, how do you verify? What methods do you use? Do you use a Bayesian statistical model to verify the machine learning?
So with regard to verification, because we have these ground truth data, basically human labeled sentences, we can do standard verification by calculating things like precision and recall and so on.
You can, or do you?
We did. Yeah.
We did. Okay, thank you.
Well, the results from the paper is sort of also a way, sort of a non-standard way of verification, right? Because we compared the scores given by claimbuster to sentences versus the decisions by professional fact checkers from CNN and PolitiFact, right? So we find that those that are checked by them indeed received high scores from claimbusters. So that to some extent suggests that if they apply claimbuster, they can potentially, claimbuster can potentially help them focus on the top-ranked sentences that can improve their work efficiency.
So then you can actually have some outcomes of predictable models based on behavioral patterns from all the data that's collected. Do you see anything driving in directions?
Say this again?
So in regards to your machine learning, does it actually understand the patterns and direction in which the data is leading towards and outcomes?
Does it understand the patterns of the direction? I'm not...
So like when you map out what the predictions of statistics are, you're going to go onto a trend. You're going to either go on a scale of an upward or downward trend. Do you get probabilities from the data that you collected?
I'm not sure if I fully understand. Maybe that, we can take this offline.
Yeah, I was going to say, this sounds like it's getting a little nuanced. It might be a great lunch conversation.
Oh, okay, yes.
We have another question at the mic.
Good morning. What I hope is a straightforward question for Claimbuster. Could you use your technique to essentially assess a candidate's internal consistency? So if you're flagging factual claims that they're making, could you compare sort of similar factual claims, e.g. the unemployment rate, or sort of against previous things they've said, and effectively automate sort of internal fact checking?
Yeah, so we are not doing that yet, but we are actually working on that. We want to develop a component of Claimbuster to compare something that's just spoken by, say, a candidate with a repository of known fact checks. So if there's a match, we can immediately tell the voters that this is true or false, right, based on the verdict by one of the news organizations or fact-checking organizations. But we don't have that at this moment yet.
Another mic question.
Okay, this is also, I hope, a straightforward question for Tobias here. So I'm David Babin, so also from UC Berkeley. So I love the idea of using online polls. I think if this method works, it would open up an incredible data set that lots of people could use. But what I don't really understand is how applicable this is to lots of online polls that are out there. It sounds like one thing you require of your method is having some reasonable estimate for what those fine-grained demographic groups are among your respondents. So what fraction of your respondents are African American between 24 and 29 of median incomes? Is that true? And if so, how did you get those estimates?
Luckily, that's not true. Our model works with pooling. So if I have, blacks in my target and I have Southerners in my target, the model works to pool these informations together to derive these finely grained subdemographic estimates. But in another thing that you mentioned, you're right. We do have to collect these background informations that we use in our model. So I do have to collect information on residency, on race, all these background demographics that we use to construct these subdemographic estimates with. We do need to collect in our primary poll. So this will lead to an online poll with, say, 8 background questions that only has, one question that we ultimately are interested in, maybe vote intention, and then 7 demographic questions. And we've played around with that at MSN.com. Obviously, that leads to a huge drop-off, right? So if you have 1 million respondents for the first question, you might then have 250,000 for the second question, but you can only use, in our method, you can only use complete data, right? People who have filled out everything. So I think that is a more that is a concern, and we're trying to work with ways to engage people so that they stay on the site and go through the whole motion of the whole poll.
Okay. So in designing the poll in the first place, you need to make sure that you're asking at least some questions about those demographics you're trying to use to recreate the entire sample.
Yes, that's correct.
Okay, thanks.
I think, we're going to take one. It's going to have to be a fast question, though. Is that a fast question?
Fast question.
Okay.
From the Claimbuster's point of view, given that you already are looking at what people say and then checking if it's true or not, would it work in a scenario where a reporter files a story and then it goes into your system and it says, you know what, these 5 sentences could be wrong based on what you've written?
At this moment, we are actually not deciding whether something is true or false. What Claimbuster does in its current form is to decide whether something is worth checking or not. So it's not able to tell you whether something is true or false yet.
But it could flag stuff like this is worth checking. You need to go and check because something's...
Yeah, so this is related to the other question, right? So we are developing that component, and if it's ready, it could flag claims that has been checked before.
And now I think Jay is going to tell us whether we get to leave or we should all stay in our seats.
The audience should stay in their seats, and my question is, could the next panel go up? And let's thank this current panel.